Good day and welcome. Today we will be looking at sketching the third degree polynomials. Firstly, you need to have a table of values. Then you have to find your y-intercept, your x-intercepts, then your stationary points, and then your point of inflection. Those are the most important aspects of this. My function I'm given is x cubed minus 3x minus 2. The first thing that I do to find the y-intercept, I need to equate x to 0. That means my y-intercept will be negative 2. Next thing that I will have to do is I need to make y equal to 0 and calculate possible values for x. So I firstly find a factor and I use the factor theorem by calculating f of 1, f of minus 1, then I see f of minus 1 renders 0. So then I know x plus 1 is a factor. My next step will be to find more factors. So I will go about and use synthetic division. When I work with synthetic division, I only list the numbers, the numerical coefficients of x and also the d value. I take the number that renders 0 and the first number is brought down as is. Now I take my divider and I multiply with 1 and I get negative 1. I add together, I get negative 1. Negative 1 multiplied by negative 1 gives me positive 1. Minus 3 plus 1 is minus 2. Minus 1 multiplied by minus 2 is positive 2. Then I have minus 2 plus 2 renders 0. How do we illustrate 0? With a dot. So, having divided by x, and the function was x cubed, that means I've got now x squared over here and x over here. Now my remaining factor is x squared minus x minus 2. Now I need to factorize, and if I factorize, I will say x times x will give me x squared and 1 times 2 will give me 2. So if I cross multiply, we'll get 2x. If I cross multiply, we'll get positive x. I'm looking for a negative x. So that means the 2 will have to be negative. So that means one of the two of them has to be negative. But if I look at the back, 1 multiplied by 2 has to be negative, so one of them has to be negative. And because 2 is in the cross multiplication as well as this one, he will get the negative sign. So my factors are x plus 1, x minus 2. So if I list all my factors, x plus 1, x plus 1, x minus 2. Remember the first one you already had. Now, this tells me that x is equal to minus 1, but there's 2 of the same roots, which means I will have equal roots that will look either like that or like this on my x-axis. And I also have x is equal to 2. Now, taking this into consideration, if I have my axis, I'm just going to draw a small little axis on the side, I will have a positive graph, which means I will start at the bottom, I will go up, then I will turn around, come down, and go up again. So it's clear to me that the equal roots will have the effect of that, and the 2 will have the effect of something similar to that. So let's continue. So my next step is to find the stationary points. For the stationary points, I need to find the derivative of the function, equate that answer to 0, solve for x, take x, substitute it into the original function, and calculate the corresponding y values. So I differentiate 3 multiplied by 1 is 3. Then I subtract 1 from the exponent, so that is 2. 1 multiplied with negative 3 is negative 3. And then 1 minus 1 gives me 0, so this will become 1. A whole number, if I differentiate it, will always render 0. So my derivative is 3x squared minus 3. But now I must equate that to 0 and solve for x. Take out the common factor, which is 3. So it leaves me with x squared minus 1, the difference of squares. When I work with the difference of squares, my factors will be x plus 1, x minus 1. Remember, then x will be equal to 1 or x will be equal to negative 1. Now I take these two values and substitute it into the original function. So f of minus 1 gives me 0 and f of 1 gives me negative 4. That means my stationary points are negative 1 and 0 and 1 and negative 4. Do you notice that that one is the negative 1 and 0 and the other one will be at positive 1 and negative 4? I will have another stationary point. Why is it called stationary points? Because the gradient of the tangent to the function will be parallel to the x-axis, which makes that then a stationary point. Now we will find the point of inflection, and in order to find the point of inflection, we need to find the second derivative. How do I calculate the second derivative? The second derivative is obtained by calculating the derivative of the derivative. So the derivative of the function was 3x squared minus 3. Now I'm going to differentiate the derivative. So that gives me 6x. Next step is to equate the second derivative to 0 and solve for x. In this case, x is 0. Now I substitute 0 into the original function and I find that f of 0 is negative 2. So my point of inflection is 0 and negative 2. Now I plot all those coordinates that I have calculated and plot them on the graph. Then I draw a smooth, continuous curve through all those given points of the function. As I was saying, that if you look at a tangent to the function at the turning points, it's parallel to the x-axis, and that's why it's called a stationary point. It means my gradient is 0. It's not moving, doesn't have a positive or a negative value. The gradient is 0. Thank you for watching the video. If you loved it, share it with everyone. If you like it, tell your friends. If it was useful, share and distribute as far as you can. Thank you for watching. We'll see you in the next video.